Hello, good morning, good afternoon, or good night. My name is Sarah Swift Malloy, and today I will be explaining why Earth stays in orbit and does not fly off into space or into the sun. As we stand on our planet, it feels like we are sitting still, but we are actually hurtling through space along a set path. We are moving about 67,000 miles per hour, or 107,000 kilometers per hour, which is about 27.78 kilometers per second. To put this in perspective, at this speed, you could travel from Forest City, Arkansas to Wynne, Arkansas in just 1 second, a trip that would normally take around 20 minutes. Our planet is in orbit. Every year, Earth completes one full revolution around the Sun, following that set path I mentioned earlier. An orbit is the curved path an object like a planet or satellite follows around another body due to gravity. This path is shaped like an ellipse, which is similar to a flattened circle or oval. But what keeps Earth in orbit? Why doesn't it fly off into space like an untethered astronaut? There are two main factors that keep our planet in orbit: gravity and inertia. The Sun's gravity is constantly pulling Earth and all the other planets of our solar system towards it. At the same time, Earth's inertia keeps it moving forward. When these two forces work together, Earth stays in orbit. Gravity is a force of attraction that pulls objects with mass or energy towards each other. We can observe gravity every day by the fact that we stand on the ground. Earth's gravity pulls us down and keeps us from floating away. The Sun does the same thing. Its gravity pulls on the planets of our solar system. Sir Isaac Newton's laws also relate to gravity, specifically his second law of motion and the law of universal gravitation. Newton's second law states that the acceleration of an object depends on the net force acting on it and its mass. Newton's laws of universal gravitation states that every object in the universe attracts every other object with a force of gravity. Gravity's pull depends on mass and distance. So even though the Earth is very far from the Sun, 149.6 million kilometers, or 93 million miles, because the Sun is so massive, it is still able to draw in our solar system. Inertia is the other factor that in this delicate equation that keeps our planet in orbit. But what is inertia? Inertia is defined as the natural tendency of objects in motion to stay in motion and objects at rest to stay at rest, unless a force causes its velocity to change. While this idea was first developed between 1600 and 1610 by Galileo Galilei, an Italian polymath astronomer, physicist, and engineer, it wasn't until 1687 that Isaac Newton codified it as the first law of motion. That first law of motion is as follows. An object at rest stays at rest, and an object in motion stays in motion at a constant speed in a straight line unless acted on by an external force. Newton's first law is completely general and can be applied to anything from an object sliding on a table to a satellite in orbit. Experiments have shown that any change in velocity, the speed or direction, must be caused by an external force. And when we're talking about orbit, that external force is gravity. The idea of generally applicable or universal laws is important not only here, but it's a basic feature of all laws of physics. In space, there is very little resistance, so once something gets moving, it stays moving, because there isn't a force to slow down or stop it. At the top right corner is Newton's cradle, which demonstrates inertia and motion. When one ball is lifted and released, it swings down and hits the others. The ball on the opposite end then moves outwards. This happens because the balls want to stay at rest or in motion. This is inertia. The moving ball transfers energy through the stationary balls, causing the last one to move instead of all of them moving at once. It shows that objects resist change in motion, which is what inertia describes. But what if something about these forces were different? Even small changes in gravity could have a huge effect on how the universe looks or behaves. I first heard this idea in the show Young Sheldon, where Sheldon explains that gravity plays a major role in shaping the universe. He explains to his mother that if gravity were slightly stronger, the universe would collapse into a ball, and if it were slightly weaker, the universe would fly apart. In reality, if gravity were significantly stronger or weaker, The formation of stars, planets, and galaxies would be very different or even impossible. Gravity is what pulls matter together to form structures like planets and stars, while inertia is what keeps moving objects in motion unless a force changes it. If Earth didn't have forward motion or inertia, gravity would simply pull it straight towards the sun instead of allowing it to stay in orbit. It's the balance between gravity and motion that keeps Earth stable and allows life to exist. In summary, the reason Earth stays in orbit is because of a balance between gravity and inertia. Gravity from the sun pulls Earth in towards it. At the same time, inertia keeps Earth moving forward from space on that ellipse-shaped path. Because these two forces are acting at the same time, Earth doesn't fly off into space, but it also doesn't get dragged into the sun. This balance is what keeps Earth moving in a stable and predictable path, its orbit. Thank you for listening.